out there, among the billions of stars in our galaxy, something impossible has just happened. A star, only 25 light-years from Earth, has exploded. This isn't a movie. It's not science fiction. This is reality. The light from that explosion is already on its way. The radiation follows close behind. And when it arrives, everything we know about life on Earth may change forever. Tonight, we're going to answer one terrifying question. What happens to humanity if a nearby star explodes? Do we survive? What happens to the solar system, the Earth, and life itself? This visualization was created using Space Engine combined with scientific models and cinematic edits. Let's begin. Not all star explosions are the same. At 25 light-years away, the danger depends on how the star dies. There are three major possibilities. 1. A Type II supernova, the death of a massive star. 2. A Type I supernova, where a white dwarf goes critical. And 3. A gamma-ray burst, the most violent event in the universe. Each one has different consequences for us. But at this distance, none of them are harmless. So, what stars are 25 light-years away? The nearest stars to Earth are mostly red dwarfs. They're small, stable, and very unlikely to explode. But if a massive star did exist at this distance, it would already be a cosmic threat. And in our scenario, that star has just died. At the core of the star, nuclear fusion suddenly fails. Gravity wins. The core collapses in less than a single second, then rebounds with an unimaginable force. The result? A blast brighter than every single star in the Milky Way combined. For a few brief seconds, that distant star outshines our entire galaxy, but on Earth, we don't notice. Not yet, because space has a speed limit, the speed of light. 25 years after the explosion, the first signal arrives. It's light. Astronomers around the world see a new star appear in the sky, one that's visible even in broad daylight. It's brighter than Venus, it's brighter than the moon. Humanity celebrates this incredible celestial event. The news spreads like wildfire. Social media explodes with pictures and theories. But while the world watches in awe, scientists are terrified. Because they know the light is only a messenger. The real danger is still coming. Hours, 2 days after the light appears, Earth is hit by a flood of high-energy radiation. A storm of gamma rays, X-rays, and cosmic particles washes over our planet. Our magnetosphere, Earth's protective magnetic shield, deflects some of it, but it can't stop it all. The immediate effects are catastrophic. Satellites begin to fail. GPS systems glitch and go offline. Power grids experience massive surges, leading to widespread blackouts. For any astronauts aboard the International Space Station, the dose of radiation would be lethal without immediate, heavy shielding. All commercial flights at high altitudes are grounded. Governments around the globe issue emergency warnings. But this is only the beginning. This radiation doesn't just pass through our atmosphere, it fundamentally changes it. High-energy particles collide with nitrogen and oxygen molecules, breaking them apart. This process systematically destroys the ozone layer. Without our ozone shield, the sun, the very star that gives us life, becomes deadly. Within weeks, the consequences become unavoidable. UV radiation levels on the surface increase by 500 to 1,000%. Skin cancer rates skyrocket. Crops begin to fail under the intense radiation, leading to a global food crisis. In the ocean's plankton, the very base of the marine food chain starts dying off on a massive scale. Even the sky itself changes color. Sunsets turn a deep, haunting purple and red. It's a beautiful sight, but it's a deadly one. Now, let's consider the worst-case scenario. What if the exploding star produces a gamma-ray burst, and that narrow, focused beam of energy is aimed directly at Earth? At 25 light-years, this would trigger a mass extinction event. The beam moves at the speed of light, so there would be no warning, no time to prepare, no defense. In a matter of seconds, the ozone layer would collapse almost entirely. The surface of our planet would be bathed in lethal radiation. Photosynthesis would stop, crippling plant life across the globe. As dust and smog created by the atmospheric reactions block out the sun, global temperatures would plummet. The devastation would rival or even exceed the asteroid impact that killed the dinosaurs. Humanity itself might not go extinct in an instant, but our civilization certainly would. So, does the solar system itself survive all this? Here's the good news. Even at a distance of 25 light-years, the physical shockwave from the supernova never reaches us. Space is just too vast. Our planets will remain in their orbits. The sun will be completely unaffected. Earth is not physically destroyed. This isn't a Hollywood explosion where planets are shattered. The real danger is the invisible radiation, not a physical impact. So yes, the solar system survives. Whether we do depends entirely on our preparation. Underground habitats would become permanent homes for millions. Agriculture would have to move indoors into massive, shielded vertical farms. Space travel would come to a complete halt for decades, maybe even centuries. Global cooperation would no longer be a choice. It would be a mandatory requirement for survival. We would finally understand a fundamental truth. The universe is not hostile. It's simply indifferent. A single star, 25 light-years away, almost ended everything we've ever known. And that, in a way, makes our survival all the more extraordinary. Space is beautiful. Space is dangerous. And above all, space is honest. Thank you for watching. If you found this journey thought-provoking, please consider subscribing for more explorations into our incredible universe.